My talk today is bashing Brittle indicators, doing red teaming on macOS without using Bash or Python. Because you see that over and over again as people using that, so I kind of wanted to break the mold a little bit. So kind of start off, who am I? So Cody Thomas, I work at Spectre Ops with Richie. I'm more on the offensive side though, so I spend a lot of time doing red teaming, doing tool development, training, that sort of stuff. Before coming to Spectre Ops, I was at MITRE, working on the MITRE attack team. How many people know MITRE attack? Okay, I like it. So I was there, did a big push for Mac and Linux to get into attack, working on a whole bunch of adversary emulation plans, doing threat intelligence, all that sort of stuff. And I spend a lot of time now working on an open source project called AppSolve, which everything here kind of ties into, and I'll give a brief overview of it. But the goal here is about the agent that's in there. So kind of overview of what we'll talk about today, introduction to JavaScript for automation and the Objective-C bridge, how all that works and how you can leverage it. I'll give a quick highlight overview of what AppSolve is and how it can be used. And then we'll dig into that, be able to use it to make a full agent, encryption, all that sort of stuff, and how you might actually use that in operation. I'll go through a couple of different tactics of execution, discovery, persistence, credential access, that sort of stuff. And I'll also go over some defensive measures that Apple's trying to do to help prevent some of this sort of stuff. So one thing to know as we go through in here, my slides are color-coded. I like to do, especially with Spectre Ops, we do a lot of offensive and defensive work. And so throughout the presentation, you'll see I try and color code the slides, whether I'm talking about something from an offensive perspective, some defensive aspects to it, or even purple, just kind of OPSEC awareness, introducing topics, that sort of stuff. So keep in mind that kind of gives a hint as to why I'm talking about certain things. So initially, straight off, we'll talk about JavaScript for automation. So what is it? Most people know the corollary to this, AppleScript, but JavaScript for automation actually started off in 10.10 in Yosemite. And Apple says it was like an AppleScript to help support controlling other applications on the system. So there's a whole bunch of different ways that you can do this already. You can use AppleScript, Perl, Python has bindings that you can use to help call Objective-C functions and do this kind of automation already. If people here are familiar with PowerShell, I like to call JavaScript for automation kind of like PowerShell version 1. It's there's a lot of stuff lacking, but it's still kind of powerful. And so all this hooks into the OpenScript architecture, which just sends Apple events to do its correlation between different processes that are running on the system. So how can you actually use it? How does this sort of thing run? So usually you'll see this run as OSA script, and then because the default is AppleScript, you have to specify the language, like L JavaScript. You can do this interactively, you can pipe things in through standard in, all that sort of standard stuff works. If you're doing this from an actual maybe Mako application or something else on the system, instead of doing it on the command line, you can use OSA kit or JavaScript for automation and AppleScript can actually quote unquote compile into script files and .apps. And so it'll take your JavaScript and create a whole .app structure, it'll compile it, give youplists, all that sort of stuff, which isn't necessarily there for you to execute your JavaScript. And that's just an example there in the script editor, just showing what JavaScript for automation even looks like. You'll see it looks a lot like JavaScript. Spoilers. So the nice thing about this, though, is that with JavaScript and AppleScript, there are these things on the system for scripting definitions. And so if you open up your script editor, you can do an open dictionary and see all the different programs on your computer that have these scriptable definitions. And all these mean is that some program decided, hey, I will allow people to send information to some API that I provide and send something back or do something on behalf of that request. This sort of information happens through Apple event messages. So that's how it's actually communicating between processes. So here's an example here just showing with Safari, you can see right in there, you can access different mechanisms, see what processes and like methods, properties, all that sort of stuff that you can access. So if you actually want to use this on the command line, you start using it, say OSA scripts, L JavaScript, I, do it interactive. And you can see right there up at the top, we'll do things like create an instance of the system events application. And so all it does is open up a handle to it, and you start accessing the different functions and properties that are available to you. So for example, you can do .current user and get the name. So in this case, Cody returns the name. It sends an Apple event message to get that. If you actually open up console, you can see these messages going through where OSA script sends this Apple event send message, system events receives it, and then OSA script gets it back. So you can see this sort of stuff happening on the wire as these messages are getting sent around. Now, if you actually want to use this, in my case, for offensive operations, there's a couple of things you kind of need to know about this. So if you want to access the Objective-C bridge, the way to call Objective-C API calls, there are two special key words/characters. So there's the $sign and the obj-c keyword. These are mostly interchangeable. So for example, you can do obj-c.import foundation and get access to all the foundation APIs and primitives in that class, in that framework. You can do this sort of thing for security, for AppKit, for everything that's out there. So now once you start doing this, because it is doing this weird typecasting between Objective-C and JavaScript, there are some weird isms. So for example, if you're used to JavaScript, you can just do quotes, make a string, and that is of type string. In JavaScript for automation, though, to access an Objective-C version of string, the NS string, it requires this $quote. JavaScript gets confused by this, don't know why, and it calls it a function. So little things like this that you have to be care of. But you can do the .js, which tries to do this automatic casting between the Objective-C underlying primitives and what JavaScript thinks they are. So you can see here, what JavaScript used to think was a function, if we do .js, now it says that it actually is the normal string text. So all these sort of things kind of happen under the hood, which can trick you up. And they're not all necessarily intuitive. For example, for some unknown reason, longs are automatically cast into strings in JavaScript. Very frustrating if you're trying to get the length of something. But you can just see there's a whole bunch of different ways that you can access and get the actual values back and start doing comparisons. So now you have some way of actually working with the JavaScript automation accesses. The next part, though, is once you want to call an Objective-C function, how do you do that? That looks crazy different in Objective-C versus JavaScript. So for example, here's the declaration on Apple's website for the launch app with bundle identifier function. And so it has a whole bunch of different fields that you can add in, like options, event parameter descriptor, launch identifier, all that sort of stuff. If you want to actually call this in JavaScript, though, it gets really annoying because everything is case sensitive and all of the parameters get smooshed together into one long function. So if you actually want to call this function in JavaScript, you have to do the whole function name is launch app with bundle identifier options, additional event parameter description, launch identifier. So you have to get all of that case sensitive each time you want to call it. It's really annoying, really fast, copy paste is your friend, but you can access all of these calls under the hood, which is really nice. So that's kind of, grassroots introduction to JavaScript for automation. Kind of useful, kind of gross. So I wanted to take all this and loop it up into this open source project I have called AppFell. So what is this? So I wanted to do operations on macOS, but what was out there originally involved like single terminal applications. You're using Empire, you're using Evil OS X, like all these sorts of stuff, not really conducive to more traditional style red team operations. Multiple people operating, you want a nice interface, you want to be able to do processing on the data you get back. So I created AppFell, which has a backend that has a whole bunch of Docker containers. It uses Python 3 to stand up a web server and allows you to access all of this sort of stuff. There's a couple of agents in there now, the JavaScript for automation. There's also Python. One of the other people on our team, Chris Ross, created a JavaScript Chrome extension agent that runs in the browser that calls back to this. The backend is all RESTful APIs, and it does some nice things like tracking your host and network artifacts. It maps all your commands back to attack. I'm a big fan of attack. And you get this nice correlation between what you actually task and the data that comes back. So it's not just a dump of data back. You can actually correlate all this information. So in the back end, what's actually happening is you have this kind of main AppFell server here. This is the Python 3 server. It communicates to a Postgres database and uses RabbitMQ to talk to a whole bunch of other containers, a whole bunch of other Docker containers, to actually do the compilations for the different agents that you're doing. It has the architecture for the different C2 profiles that you're trying to talk to, all that sort of stuff, kind of Dockerized out there. And so you can see here loosely, you use a browser, connect into it, super easy from the operator side, connect into the server, and the agents call back through these C2 Docker containers. That's just a high-level overview. Not really what this presentation is about. But now I want to take all the kind of information that you know about base JavaScript for automation, and I want to turn that into an actual agent I can use in red team operations. So the first part, you need command and control, right? Standard C2 for any agent that you want to use. Well, as we go through designing this for operations, I kind of want this to be resilient and able to be used for a long time. So I had a whole bunch of design considerations that I brought into this. So the first one being for command and control, I don't want the agent to have to know about any of the implementations. So whether you're using HTTPS, Twitter, you're doing Stego in like some images you're posting somewhere, I don't care. The agent shouldn't have to care so long as it just knows a certain few API calls, like get tasking, post response. The actual implementation of how it happens shouldn't matter to the base agent itself. So that way you can kind of swap out your actual C2 mechanisms on the fly, because it doesn't matter if the API stays the same. As you go through and you start doing this, I initially did just HTTPS. That was fine for me as a proof of concept. But once you start going through and using this in operations, you need to kind of step up your game a little bit. You need additional layers of encryption going inside of it. So I started using Apple's security framework to do encrypted key exchange as part of the whole command and control protocol. So in here, you can see a little snippet there at the bottom. You have to be very explicit in how you do the encrypted key exchange and anything security related within JavaScript automation, because you have to do all these crazy long function calls and parameters and all this sort of gross stuff. Learned a lot of things along the way, as well as something kind of interesting. So I call this a win, but it's Apple, so take it with a grain of salt. So as I was going through and I was doing the encrypted key exchange, I was doing a lot of stuff with AES encryption. And so now, if you don't know a lot about encryption, a big thing that comes into this is your IV. So this should be a random value. Okay, so I went to Apple's documentation, and as part of this, there's a set IV key. Like, okay, awesome, I need this. Their description says, if you don't supply a value, an appropriate one will be supplied for you. Like, sweet, I don't have to generate a random number. Apple's going to do it for me. Started testing this, and I was like, this is weird. It always seems to be 0. So I go through, I look at the open source documentation, and sure enough, it always falls through to a base case of 0. That's not a appropriate value. So I emailed Apple and said, hey, all the steps, this is not right. It kind of breaks all security. And so their response, behaving as expected. Okay, thanks, Apple. But they did update the description and say, you absolutely should be supplying your own random bytes because the default thing that we do is super bad. So kind of win, kind of not, but it's Apple's philosophy. So that's kind of getting your C2 set up. So after that, now you have to communicate in some way. How are you sending messages? So like I said, I wanted this to be resilient as I move forward. And so one of the things I did that most people do whenever they think about C2 is you can adjust whatever URI you want if you're communicating over HTTP, right? You shouldn't be calling back to post my response from command, right? This sort of stuff should be changeable. I also wanted to add in this little extra feature, these dynamic endpoints. If you do a get tasking request twice, I don't want it to look the same both times. So I added in these little features where you can specify anywhere within the URI these M, A, and N kind of prefixes to say, for example, here N15, every time you do this request, put in 15 random numbers. I don't care. Or 15 random alphanumeric characters. So you can make sure that all of your requests look different. Helps make you kind of blend into the noise a little bit better. One of the annoying things about this, though, is despite being JavaScript, you don't have all of normal JavaScript capabilities that you might have if you're executing JavaScript in a browser or Node.js. So you can't just do like XML HTTP request to start sending out your information. You have to hook the Objective-C API calls under the hood. So that's what's happening down here at the bottom, is you actually have to specify that mutable request, put in the encodings, make it lossy conversion, add in the parameters one by one, all that sort of stuff. Super gross, but doable, and just hooks API calls under the hood. So now that we kind of have this command and control structure set up, now you have to be able to do things, right? You need modules in here that you're going to execute. One of the nice things about this being JavaScript, though, is that it's not compiled, it's interpreted. So you can add in new functions as you go without a whole bunch of headache. By default with this for JavaScript, I just use eval. So you can go through and give it some string of code, eval it, get an actual function back, and now you can do this mapping between function name and actual function call without having to do anything crazy. So it's kind of taking this to the next step. As you go through and you start sending around payloads, especially if you're doing phishing, you don't necessarily want to leak all of your capabilities at once. If you send, hey, my initial payload, if it's caught by maybe AV, saying I can do these 15,000 things, you just burnt not only that campaign and that payload, but all future ones potentially, because now it's in signature each thing you can do. So what if you just sent the bare minimum to your payload or to your target or whatever, essentially just exit and load, right? Now, if the defender catches your payload, they see, okay, this can communicate over C2, and it can run things and exit. Okay, they don't necessarily know maybe where else you moved to, how or if you stole credentials, any of this other sort of stuff. If you're loading that all into memory per agent, now it's less for them to see. So I kind of go down that route whenever you build payloads in Appel and use this payload specifically. I have a whole bunch of commands down there that you can load, can do a whole bunch of crazy things on the system, all using JavaScript automation. But ideally, whenever I do this, I just put in the payload, exit, and load. So now that we kind of have the base of this agent we're going to use, let's do something with it, right? We need to operate. That's kind of the point. So notice blue, just talking defensive side. Typically, whenever we look at execution on macOS, and we saw this kind of a couple times already, people will curl URLs and type them into bash. They'll echo base64 encoded strings, then type them into Python. They'll make scripts. Like all this sort of stuff is normal that you see malware do over and over and over again. So from our side, what can we do that's a little bit different? So one of the nice things about being able to use eval and API calls under the hood with JavaScript for automation is I can do a one-liner that just uses Objective-C API calls to pull down the code and execute it in memory. The nice thing about this is I'm using OSA script, so it's a native signed Apple binary, and I'm just pulling down code and running it in memory. So there's no gatekeeper, there's no signing, there's none of that coming into play. So it's nice that it kind of just bypasses all of that. You can reach out and pull down evil.com/evil right into memory, eval it, and you're good to go. If you want, you can go through, like I said, JavaScript for automation and AppleScript can be compiled into these script or .app files as well. Certain things that you need to do enable require these sorts of different compilations, and I'll talk about these a little bit later that require it. But if you need to, you can easily compile either in memory, or you can use OSA compile, or you can use the script editor. There's a whole bunch of ways that you can get these additional files out of it. And of course, you can just double click them and they run. So it's pretty straightforward, pretty nice. But one of the things that you should know about this, as you go through, lots of malware authors go through and use this do shell script functionality to do AppleScript and thus call whatever additional script or payload or whatnot they want to do. If you actually call this do shell script, what happens under the hood is you're spawning bin sh-c and then the command that you specified. I don't know if you guys are familiar with the Windows world, but on Windows, we sort of see this sort of stuff all the time with things like Cobalt Strike, where people will do shell in a command and they spawn cmd.exe, waxc in the command. It has become widely known as a horrible indicator. People doing this sort of stuff all the time. No normal person types that on the command line. So people do this all the time on Mac, and it should be the same sort of thing. If you see this bin sh-c thing, how often is a normal user sitting on the command line typing that? Right? This is the sort of brittle indicators that I'll keep talking about. You should be thinking more about what's actually happening, what causes this sort of stuff. An additional thing to note about this as well is if you actually access bin sh on Mac, it's not actually bin sh because Apple, so it's actually bin bash emulating bin sh. So that comes into play for more things I'll talk about later doing persistence, but it causes some oddities, like you can't just background a task. So keep that in mind if you're going to go through doing this sort of stuff, or if you start using bin sh and other things in operations. So as we go through, now maybe you're going to spawn use shell, do the bin sh-c, okay? You're going to start executing things. One of the things people do all the time, they need to sudo. Well, if you're doing this kind of asynchronous callback and you're just spawning commands, right, doing the do shell script, you don't have the ability to, like do file descriptors and be able to type things into standard in. So how are you accessing sudo? How are you doing things elevated? JavaScript has their back on this. There's actually a piece in here that you can say for do shell script with administrator privileges. Awesome. You can also specify what you prompt to the user whenever you do this. You can say whatever you want. You can also specify whatever icon you want to use and all sort of stuff, or other sort of stuff. So Definitely doesn't have to look legit. You can make it look like whatever you want. That's prompting for creds. If you have the creds already, you can use the same sort of thing and supply these two additional ones, username and password, pass them in, and now you're essentially doing sudo. A kind of third bonus, thanks Apple, is there's this kind of, in the collaboration framework, if you do the identity with name, there's an authenticate with password function that you can do. That all its purpose is to tell you true or false if this password is for this user. Doesn't spawn a process, doesn't seem to have a lockout capability, so you can essentially brute force natively API's passwords. Thanks. So as you go through and you do this though, one thing you should note, if you're doing this with administrator privileges, you're not calling sudo, but you're doing something else. So this goes back to knowing kind of what tools happen under the hood. And one of the things here that happens is you're calling a security off trampoline. And so in the end, instead of doing like bin-sh-c ls or whatever, spawning that command, bin-sh-c ls, and then the command ls, when you do it this way, you're actually spawning 5 different processes in a row, very quick succession, to get the security off trampoline and everything set up to then just boil down to whatever command you try to execute. So here's an example of what it looks like. This is using monitor from FireEye Mandiant. It goes through, you can see here, I was just doing who am I? And you can see there is what you would expect, the mismatch, as I'm trying to do things as root. And you can see down here at the bottom, my user, it's a feature, went through and you can see the security off trampoline. You can see scripting additions getting launched multiple times, boiling down to root, which then just in essence comes down to, again, bin-sh-c who am I and who am I. So you kind of need to know what's happening under the hood. Don't necessarily look for sudo happening as an indication of some adversary using elevated permissions, right? There's a whole bunch of different ways that you can go about doing this. So that's kind of execution. How are you going to do things in this operation? Next part is looking at discovery. How do you figure out what's going on? Typically, adversaries go through, they do ID, who am I, ifconfig, DSCL, hostname, like all that sort of stuff. They're running all these commands in quick succession to try and figure out what's happening, where am I, what exists on this box. And so an example, this is coming from a Carbon Black report talking about a Schleyer variant. So you can see here, they did a whole bunch of curls and stuff pulling down a script, that then just goes through and runs a whole bunch of commands. So from a defensive perspective, that looks kind of abnormal, unless this is coming from a push out from your MDM or whatnot. Just these wide range of discovery techniques happening in quick succession, usually not a good thing. But do we really need to spawn all those processes to get all this sort of information as an attacker? Not really. This information, most of this information is stored already on disk, and that's just what these binaries are pulling down for you. So I went through and I wrote 2 additional tools to help with this. To get local information, what's happening on the system, I wrote Health Inspector. And to get stuff from the domain, if you have a domain joined system, is Orchard, because a forest of apples is orchard. Yeah, sorry. So for doing local discovery, what I go through and do with Health Inspector is just read files. Right, this is the most innocuous thing. Most people don't look for this because it would overwhelm your sensors, overwhelm your analysts of just looking at file reads. But there's a lot of interesting things that are kind of there on a system already, stored in these different p-lists. Specifically, I go through and I look at your library preferences and the system preferences to kind of pull information. So, yeah, on Windows, you can actually help combat this a little bit because of the idea of SACLs. You can kind of get alerts on specific reads or actions on files. On macOS, this is a bit harder. You kind of have to go through, do some sort of tweaking with AutoD. It's kind of gross. And you're still probably going to get inundated or slow down your center trying to parse through all this information. But you can see down there at the bottom, super easy from JavaScript for automation to go through and read these plist files. Essentially, all you do is you call one function that says, create a dictionary with contents of this file. plist files are already dictionary objects, whether they're in XML or binary format. So Objective-C under the hood parses that for you already, which is awesome. So this is the first iteration of Health Inspector. This is all the stuff that goes through and pulls for you, parses back, and gives you interesting information. So you can see here a couple interesting ones are going through to look at launch services. So you can see which programs have URL schemes registered, what programs are associated with what file extensions. You can see logon items. You can see which programs are specifically allowed through the firewall. You can see what kind of groups you're in. You can see how many like virtual desktops a user has and which one they're currently using. All this sort of crazy information, just stored inplists. No need to spawn any other processes. You're just reading files on disk. So you can see a couple of these. You can also see all software that's installed on disk, the versions. You can see SMB information, what programs are docked on the side, which ones are set to reopen, which other things are there, all this sort of crazy stuff just by default. From an offensive perspective, you can also see kind of extra consequences. So for example, you can tell from the Finder preferences if people see the hidden extensions or the default extensions for files. This gives you kind of clues of what you can and cannot do as you try and hide things if the user is just browsing on the system can see those not. So all this sort of stuff you kind of read into as the offensive side to get a kind of better lay of the land, what's going on. So as we move past local information, we start looking at, okay, this computer in relation to everything. Most people will go through and look at DSCL, LDAP search, DS cache util, all these sorts of things to kind of look at how the computer is configured in the environment. That said, lots of times people have MDM, and so they'll just have like a JAMP configuration where it's not necessarily joined to a domain. But if it is joined to the domain, which kind of happens more and more these days, there's a lot of crazy stuff that you can see in here. And so with Orchard, what it's doing is it goes through and uses Open Directory, which is Apple's gross version of Active Directory. It goes through, you can use it to query everything locally and remote. The biggest limitation I found so far is that you can only query within your forest. I haven't been able to figure out how to get it to query across a trusted forest boundary. That might just be a limitation between Open Directory and Microsoft's Active Directory, the way they interact together. But if you're using DSCL from the command line, essentially it's pulling the same sort of information. You're just not having to spawn this DSCL binary. And so whenever I wrote this, the kind of goal here is to have a Mac equivalent of PowerView. Most people use this to go through and do a lot of their Windows operations, but we didn't really have anything on Mac for this. So I went through, started doing a whole bunch of different commands, kind of mirroring the PowerView style. And you can specify whether you want to hit the Objective-C APIs under the hood, or if you want to do the more traditional route of actually spawning DSCL, DS cache utils, all these sorts of things just outright. This kind of variation allows you to test more the varying levels of defenders. Sometimes just going all out super stealthy isn't the best option. You kind of need to ramp things up a little bit in terms of noise level to be able to find the threshold to actually get defenders a thread to start pulling an operation. But here's an example going through. One of the annoying things about Open Directory for Apple is it has all these kind of prefixes of whether something is a standard type or a native type. And these also come into play whether things are cached or not. So you can see here just doing a quick query against a computer that's joined to the domain called test. You can see the SID of the domain, you can see what groups you're a member of. This thing down here at the bottom, the Apple meta node location. If you're using DSCL, you'll have to query things like Active Directory / the NetBIOS name of the domain / and then if you want to get more specific inside of your forest, you can specify the fully qualified domain name of whatever subdomain you're trying to access. So this Apple meta node location is giving you that full path of where it's pulling this information from. Kind of handy if you're trying to mix the two or you're trying to get extra information. So that's a kind of intense overview, lots of different querying stuff you can get. No need to actually spawn all those different binaries to get a lot of this information. Now we'll start talking about persistence. So typically, whenever we start talking about persistence, and we've seen this from a couple talks today, adversaries will go through and create launch agents, launch daemons, cron jobs, login items, like all this sort of standard stuff. But is that really necessary? Do you have to do that? Is there anything else you can do instead? Turns out there is. So on macOS, there's this feature called folder actions. Is anybody here familiar with these? A couple? Okay, nice. So folder actions essentially give you a way to automatically process and do something whenever a folder has an action happen to it. This action could be the folder is open, closed, file added, file removed, all this sort of stuff can trigger a script to happen. For us, that's nice, but it does require the script to be a .scpt file. It has to be a compiled script. And I give quotes because if you compile like a JavaScript or an Apple script, like standard text file into that SCPT, you can essentially just pat it and see 99% of it just plain text, just ASCII. But you can go through and have all this sort of stuff happen automatically. These features of folder actions is a sub-aspect of the system events process. So as you see, we'll go through and you have to interact with that in order to do this programmatically. Additionally, you can have multiple scripts per folder that kick off. And these scripts are not actually executed by you or root. They're executed by this folder actions dispatcher. So this is kind of nice because you can have this kick off at a later time. And like somebody was mentioning earlier, it's not necessarily tied directly to your application or your process that set this up. It's tied back to this folder actions dispatcher daemon that goes through and tries to kick it off. So if you do one of those pop-ups for the Apple event messages between two different things, it says like terminal wants to control whatever, it doesn't actually come up as your process. It comes up as this folder actions dispatcher, which is kind of nice. Now all these sort of changes go through and they happen to this com.apple.folderactionsdispatcher.plist. If you want to actually go through and pull this out and start messing with it, it is really, really gross because Apple. And so it has a plist with 2 or 3 additional plists inside of it that are encoded in base64 and then binary plists and then more encoding inside of that. And it's super gross. I don't know why they do it. But by default, folder actions are disabled on Mac systems. So if you actually want to do this from an offensive perspective, you have a couple things you have to do. You have to take this JavaScript for automation, you have to compile it. So you can use OSA compile, or there are actually Objective-C API calls that you can do that will compile this in memory for you. And so that's what's happening here down at the bottom is essentially you can just take the script, here I have it up here, say that this is JavaScript, do OSA script will allow you to kind of create this in memory, say compile and return, and then you can just write it out to disk. That's kind of nice. One thing to note here, as I was talking about where bin bash, or bin sh is really bin bash emulating bin sh, you can see here, it's really gross, this ampersand greater /dev /null ampersand is actually the proper way with this weird emulation to background a task. So if you just do an ampersand, it won't work. It'll just be a normal process. You have to do this weird direction stuff to get it to actually happen. So if you do actually kick this off, doing it, whenever the process runs to execute your script, a couple things happen. One, that folder actions dispatcher daemon goes through and actually executes it for you. But when it's running, up a little top in the icon bar is this little cog that spins that shows that you have something running. So if you're trying to do this as an adversary, it's kind of gross because you have that sort of thing spinning up there, but it's only spinning while the initial process is running. So if your whole thing is maybe a download cradle to then execute something else in the background, the little cog only spins for that half a second that the initial script executes. So you can kind of get around that whole point of it showing that something's running. And so like I said before, all of this feature comes from the system events application. So you can see down here at the bottom, it's as simple as getting a handle to system events, saying, hey, I have a new script. It is located on the desktop. I want to attach it to a new folder, give the path to the folder, then just push it to the list of scripts for that folder. Super easy. And you can easily just set globally that folder actions are a thing by just doing .folder actions enabled equals true. So pretty straightforward from an offensive perspective, and it gives you a nice level of persistence that's way different from what people are normally checking for. The next thing I'll talk about is doing injection. So typically, whenever we think about injection, we think in the Windows world where you have 2 processes, you're opening, getting a handle to the next process, allocating memory in it, putting your code in there, starting a thread, all that sort of stuff, right? That's the normal process to go through and do this sort of injection. But if you think about it, the whole goal of injection is just get that other process to run code for me. It just so happens that on Windows, the easiest way is to go through that laborious process of actually shoving your code in there and running it. We, though, kind of have a nicer option. So remember, like I said before, lots of applications have these scripting definition files that expose these APIs for you to do stuff. The most common one that adversaries use is this do script in terminal.app, which executes a script for you. But there's a whole bunch of other things that kind of go into that. So you can see here, not only can you say do this script, if terminal.app is open, you can say, hey, in this terminal, in this tab, run this script. You can also say, hey, in this terminal, in this tab, show me everything that the user sees and show me the whole history for that tab. So you can kind of get all this sort of information programmatically. But the goal here is that you're able to say, this tab, run this specific thing for me. And that's as simple as saying, getting a handle to the terminal and saying, do script ID in this first window in this first tab. The downside here is that the user sees what you see because you're just sending these commands into that terminal. So if you maybe send this command in here and you don't want the adversary, you don't want the defender or the user to see it, you can still then issue more commands like clear or exit or whatnot. So the thing there that's also super nice is if somebody is in that terminal and maybe SSH into another computer, now you can put commands into that terminal and get execution on the remote computer. So you're kind of able to enable injection and lateral movement just by putting this, running these codes in different places. Now this isn't just a terminal thing, but a couple of people talked about this a little bit earlier, where Safari.app and Chrome.app both also have this do JavaScript functionality where you can say, hey, this tab, run this JavaScript for me. The interesting thing here, though, is that as of earlier this year, like January, February-ish, there were actual issues opened up in Chrome about this specific thing, saying, hey, this is a vulnerability. People can just run arbitrary JavaScript in any of the tabs. And the resolution was, yeah, but Safari allows it, and that's a feature, so we can't not do it. So for whatever reason, they allowed it for a lot longer than they knew they should have, until finally Safari went through and added in that little feature where you have to check, allow JavaScript from Apple events, and then Chrome and others followed suit to say, oh, okay, it's not a feature anymore, now I can block it as well. Super stupid, but hey, what are you gonna do? Additionally, like I said, this isn't just terminal.app, it's not just one program or another. There are a whole bunch of things out there like iTerm2 that a lot of people use instead of terminal.app allows you to do the same thing. So I definitely recommend as you go through, look at what software you put on your system and what scriptable interfaces are there. They expose way too many different features than they should. And so the defensive thing about this is noting that this allow JavaScript from Apple events is disabled by default, but it's a preference that a user sets. So if you go through, if, for example, on Chrome, if Chrome is currently closed, in application support Google Chrome default preferences, you can write in allow JavaScript Apple events true, and the next time Chrome starts, awesome, it's true now. Now you can do your injection. So super easy to bypass, but it is disabled by default, so that might be something that you can check for. So the next thing I'll talk about is getting credential access. This is kind of a big one as we go through and we do operations. Typically, people will go through and use a security binary to try and dump keychain. They'll use DSCL or defaults read to try and read the shadow hash data. If you guys aren't familiar with this, on macOS, instead of having like the SAM and security files and stuff like they have on Windows, they'll go through in the user's plist file, they'll have this shadow hash data, which is a couple of different versions of the user's password hashed. The most common one here is PBKDF2 with, I think it's AES256. Going through to do all these different hashes. Additionally, people will go through and try and export a keychain or read SSH keys, all this sort of stuff that people see over and over again. One nice thing about Orchard, though, the kind of domain reconnaissance tool that I wrote, is going through, if you have a domain user logged into your system, or you have a local user logged in, if you execute as root and do just a query of read information about this user, you can get this shadow hash data, which means if the domain user is logged in, now you have to hash to that domain user's password because that data is cached locally. Now, it kind of makes sense that the data is cached, though, because if the user is domain joined and they close the computer, restart, come back on, and they can't connect to the domain, they still have to be able to authenticate in some way, right? So this data has to be cached somewhere. But you can just query it and dump it right here, and as you can see, yeah, there's a salted 512 PBKDF2, and there's essentially the hash and the iterations needed to just plug it into John Ripper or Hashcat or pick your favorite hash tracking tool and go through and dump it. Pretty easy there, and with using Orchard, using Open Directory APIs, you don't actually have to spawn any processes to pull this information. Additionally, like I was saying, the information for a domain user is cached in local defaults, and you can see a whole bunch of this different information is what's actually cached from there. Part of that being the shadow hash data, part of it being what groups they belong into, how things are authenticated. This authentication authority, you can see here, first thing it does when it checks is the local cache user that's there. If that's not able to be found or something is wrong with it, it'll fall back into Kerberos and then fall back into just creating a shadow hash if possible. So you can see this different authentication authorities and the processes it goes through to try and do this authentication. One thing I'd like to remind people though, is that especially as you start doing operations and you look at defensive, passwords are more than just hashes, right? People are authenticating, getting around a network, and doing your job with more than just a password hash. Especially as we go through and start talking about Kerberos. Kerberos by default is on macOS. Now, granted, it's some weird Heimdall version of Kerberos, but it is still there. And with Orchard, for a local user, you can pull off the Kerberos keys and the Heimdall SRP key. And if you're looking at a computer joined to a Windows domain, as you start doing Kerberos, there's a whole bunch of information stored in this etc krb5 key tab file. krb5 just being Kerberos version 5. By default, this file only has reading rights for root, but if you're part of any of these other groups, you can actually read it. So if you're part of Calendar, Jabber, Postfix, Team Server, key tabs, mail, like all this sort of stuff can read this file. All you need to do is read it, because then you can get access to these keys. So this is a binary formatted thing, so you need to write a parser. I'm using this as well. It's called the key tab parser. Goes through and you can pull out all these different keys that are there, all the different versions for them. One of the things, if people are familiar with it, that I like to compare this to is, especially since we're talking about Kerberos, these are the keys for the SPNs, for the service principal names. You can think about this as the keys required to do silver tickets. So you can use these to be able to get access to this service on this computer. So for example, if you have the host key, you can then use that to get access to the file system on that computer. Right? So all this sort of stuff comes into play, but it's more than just the user's password hash, right? Additionally, if that's just the hash of the password to get a silver ticket, there's more information past that. You can now start talking about TGTs, the ticket grantor ticket. By default on Linux, this information is stored in temp krb5 cc files, which you can just read. On Mac, though, you can use the klist function, binary that's by default on systems, and you can see where these credentials are stored. By default on Mac, these has little parameter here of API instead of file, and so you have to do API calls to pull this sort of information back. Sounds hard, but it's actually doable. Now, the annoying part for us, though, if we're using JavaScript for automation, is because JavaScript is this weird instance of trying to figure out whether it's scriptable, if it's Objective-C, is it whatnot, how useful it's trying to be. It's really bad at unpacking structures. And so you can go through, you can pull out this file, you can pull the data back, but you can't then parse into it to pull out specific like fields within structs. But Heimdall has a whole bunch of APIs that you can use to pull this out programmatically. And so you can just compile a C program that goes through for each TGT that's on a system and pull out the actual key itself. Pretty easy and useful. So now the last thing I'll talk about, since I'm pretty close on time, is looking at the defensive measures that Apple has kind of put into play to help prevent some of this. This was already talked about a couple of times today. With Mojave, it goes through for every tuple that you're trying to access. So for every initiator and receiver program, there has to be a new prompt for whether you consent or deny this. The annoying thing here, though, is that you'll only ever get the prompt once. So if you go through and say terminal tries to access system events, and the first time the user sees it, they click deny. Every other time after that that you try and initiate that connection, you'll never get a pop-up. You'll get an automatic deny. The annoying thing about JavaScript is that this comes back as error, error. So you don't get a lot of information about it. But if you want to reset that, you can do what they mentioned earlier, going through with the TCC util and just reset it. But you'll only ever get one pop-up for every tuple that happens. Kind of annoying. And this is just an example below of what shows up when you try and do that request. Additionally, like I said here, you can use the TCC util to go through and reset this. Additionally, You can see here it's for every specific tuple. So if you try and access system events and Chrome separately, you get a pop-up for each one, and they can just be toggled of whether or not you want to approve or deny them. Oops, sorry. Whether you want to toggle them. This is kind of similar to the universal access auto warning plist. This is something that Health Inspector will go through and parse for you as well. This one goes through and gives you an idea of which programs have ever prompted for access into universal access. It doesn't tell you whether or not they were approved or denied, but just gives you a running list of everything that ever prompted for access. And so one of the things I'll kind of leave you guys with as we start talking about defensive aspects and brittle indicators and what are all the different ways that adversaries can do things on a system is to start looking at the minimum viable access to achieve a goal. What's the least amount of information an adversary has to know, or the fewest things an adversary has to be able to access to achieve some tactic? Are they trying to get credentials? Are they trying to get domain information? Are they trying to laterally move? Like all this sort of information, it helps as you start trying to craft these behavior-based analytics and get down into the root cause of why adversaries and people are able to do this. You figure out the minimum access needed. You'll have a lot better time of being able to catch all these things you've never thought of before without having to write a specific detection for each one individually. Again, it comes down to also identifying where your kind of crown jewels or the things that you find have the most sensitive information, where that actually lives. Are you just worried about SSH keys, plain text passwords? If you're worried about all authentication, make sure you take into account all authentication, Kerberos keys, environment variables, API keys, like all this sort of stuff has to come into play. And so as we go through, people tend to immediately jump towards obfuscation. Like, I can get around this detection because obfuscation exists. I think that works in the defender's advantage though, because this sort of stuff down here for cat etc passwords, that should never ever fly past you as a defender. That looks super weird. Obfuscation itself, for obfuscation's sake, is in and of itself like a flag. It should be an alert for you. This sort of stuff, a user is never going to do. Your sysadmins are never going to do this. If you start seeing all this sort of crazy stuff, it should be an easy flag for you. So the fact that defenders are able to, or that offensive malware authors are able to go through and do this easy obfuscation and get past these brittle indicators, shame. You should be able to get past it. You should be able to block this a lot easier. So just kind of remember that as you go through. One of the things I do to kind of help with this, from both the offensive and defensive side, is in @fel, as you go through and you start trying to do operations, as you execute commands, I track, before you even execute the command, what kind of effect you'll have on the system. So for example, like I was talking about before, doing the elevated permissions without having to spawn sudo, I tell you right up front, here are the 5 things that are going to be spawned automatically whenever you execute this command. This helps you from an offensive perspective, knowing what's actually going to happen. This helps you from a defensive perspective as well, because now you can see these different kind of variations and see, these are the sorts of things that might look weird. Let's start digging into why. And so you can see here it replaces the information that you're actually executing. And so that's kind of the last of my talk. I think I'm right here at the end. All the tools that I mentioned, @fel, Orchard, Health Inspector, KeyTap Parser, all this sort of stuff is already up on GitHub, available, or you guys can bolt down, mess with it. I also have in there like how to actually run it, how you can execute it within @fel, how you can just execute it normally, all that sort of stuff. Thank you.